So hello and welcome to the University of Plymouth Open Day, Virtual Open Day. And my name is Simon Usher. I'm the admissions tutor for chemistry. So I'm very pleased to meet you online, and I'm really pleased you've chosen to join me today for a presentation about our BSc and MChem chemistry courses. And indeed, this presentation is also for anyone who's interested in thinking about what type of degree to choose. So I've got a couple of questions to deal with today. The first one is, why might you actually study chemistry at university? And the second one is, why would you come to Plymouth? What does Plymouth have to offer that you'd find attractive? So we'll talk about those two topics. So the first one is, why study chemistry? So the number one thing we look for is people with real passion for science, and sometimes people aren't really sure whether they do have a passion for science. So to give you some examples of the type of mind that scientists have, I've just chosen on a few things. So really critical and investigative minds, so the sort of people who ask these types of questions. So how was the universe formed? Why is infinite space something which we find it hard to comprehend? How do medicines actually formulate, how are they formulated and then target specific illnesses in the body? Something that's very topical at the moment. So those kind of questions that often seem quite naive, like why do flowers smell sweet, are actually the sort of questions that if you ask your parents, guardians, friends, even your teachers, you probably feel like you haven't quite got to the bottom or got a satisfactory answer to your question. And that's where really we come in at university to really delve deep into how things work and what makes things tick. You need to consider and increasing your knowledge and understanding through higher education. I often pick on a good example of this. So in an open day presentation, I sometimes bring in just a leaf. So we've got a picture of some leaves there on the screen in front of you. And I like this example because just by taking a simple sort of thing which is all around us, we can sort of start to focus in on the chemistry and why that might be interesting. So leaves are a good example because inside a leaf there are molecules. Well, there's a molecule called chlorophyll, and that's a cage-like structure of carbon atoms, and it actually traps a magnesium atom in the middle. But the cage-like structure is absolutely tuned perfectly to capture a certain wavelength of light that allows the process of photosynthesis to take place. Excuse me. And why I find that particularly fascinating, because actually the process of photosynthesis started over 3 billion years ago in the ocean, and we know this because we're able to sort of study the history of organisms called cyanobacteria. And cyanobacteria I find very fascinating, and it's actually something I study a bit in my field of research in marine chemistry. They're very fascinating because they're over 3 billion years old, and this bit of chemistry, this bit of machinery for harvesting the sun's light is almost like a chemical fossil. It's been transferred from one plant to another over billions of years via the process of reproduction and DNA being resequenced over and over again. So just by looking at, I like that example because it just demonstrates that just by taking something that's just around us all the time, we're able to really delve into the chemistry and the history and all of the implications of the chemistry. And actually, personally, I find that kind of thing absolutely fascinating. So just to show you an example of, as I said, ideas, thoughts, and having that passion for your science And if you've got that, then really, the university, I think, is for you. So another example we often look at also in these types of presentations is perhaps where we've got in terms of making things and our chemistry, the man-made chemistry, if you like. And I like this example here of just taking our everyday smartphone and looking into what it's kind of taken humanity to do to actually get to the point of producing a smartphone, which we just almost take for granted now. And smartphones are fantastic because within a smartphone, you've got, let's say, about half the periodic table in terms of all of the elements that are used. And you think about it, it's actually taken sort of hundreds of years, or could say thousands of years of alchemy and chemistry to purify the elements and understand how they work and what they're good for and what they're bad for, to actually get to this stage of using them in this kind of way. So that's taken a lot of hours of chemists working in smoky labs under quite bad conditions, often not paid very much back in the olden days, because scientists were often only just sponsored if they were lucky for the work they were doing. And that's now led to the point where we have enough understanding that we can use things like indium and tin and actually put them into a material so that you actually have a touch screen that you can use on your phone, all the way to some of the more exotic elements such as dysprosium, praseodymium, they're shown in purple, and those are examples of the rare earths and the lanthanide series in the periodic table. And availability of those now means that we have very, very magnetic materials which can be used in things like smartphones to produce sort of high quality speakers and microphones. So that's just a really good example of where we're at, and we're getting quite good at chemistry now. But I still would argue, when we compare to the chemistry of biological materials and organisms, we're still learning from the masters there. So on to some more sort of practical stuff about chemistry. The thing I like about chemistry in terms of being able to inform people of whether or not it's useful is that actually chemistry can be thought of like a profession, just like being a doctor of medicine, just like being a lawyer, just like being an electrician. All of those things require people with knowledge and skill. And so it's not just a purely academic subject for the sake of it. It produces graduates which have a whole range of practical skills and transferable skills. And employers do really like chemists. They have often good problem solvers, and they can really make improvements in businesses and industry. And that's because when you're a chemist, you have to be numerate. You have to be able to understand the consequences of ordering 10,000 against 100 million types of product. Knowing how to handle numbers safely and not making big mistakes. We're also, as I said, problem solvers. We're constantly solving problems throughout a degree course. It starts in year 1 all the way through to year 3 or 4. These days, it's really important to be able to handle data. So getting large databases, being able to manipulate them, perhaps even use some code to sort of transfer them and use them in a specific way. We have to be quite observant. Now, some people are better at this than others, but generally, by being a scientist, you have to be able to observe, and that's part of your training in the lab. And you'll find that that's really interesting. You have to be critical. Now, that doesn't mean you just go around saying, "Well, I don't like your shoes," or I don't really like the weather outside today. Critical means that you ask questions. So if someone says to you, "We're going to create this product and we're going to charge £5.40 for it," rather than just saying, "Oh yes, okay," you'd be the sort of person that might say, "What is the product, and how can we improve the way that we do it? How can we reduce the cost?" So graduates are people who don't just do things, which can be perhaps almost irritating for employers initially, but you tend to be found in places where decision making takes place. So tend to be found in in areas where you have to actually think about what's going on, ask questions, and make important decisions. And you have to be able to communicate. You've got to be able to tell people about your science, the data, the changes that are going on, and that again is a real skill to do that well, believe me. So there's all these transferable skills, all these things that you get from a chemistry degree, which, as I said, employers love that. And when we ask sort of where do we find chemists, they're quite hard to spot because they don't always wear lab coats and have crazy hair, as everyone thinks. But actually, chemists are sort of everywhere within society working. Obviously, big questions at the moment are energy and the environment, in terms of how we work to have a sustainable planet, how we provide energy for the processes and the industry and the heating that we require. And those are really big issues, and we're right in there with our research and our chemistry at the moment, particularly in Plymouth. Then obviously human health, and at the moment that's a clear topic which you can see the importance of, that's with the impact of the COVID virus at the moment. Lifestyle and recreation, chemists are required to create pharmaceuticals, products, toiletries, all sorts of things, materials, any kind of material that's not natural, such as wood. Chemists have to get involved to produce that and test it. And then there's lots of chemists that go into other things, journalism, chemists that go into teaching, chemists that go into law and actually provide analytical data or work in courts. So really, the sky's the limit, I think, and you can work all around the world as a chemist. I've worked in lots of nice places. Really, it's up to you to sort of use your imagination and get involved and help in the way that you can. So here's just some examples of chemists. So you've got research chemists, analytical chemists, food chemists, scientific journalists I mentioned, climate change, working in polymers and plastics, fuels and derivatives. And more recently, there's more interest in green chemistry, doing reactions that don't leave the industry with a whole load of toxic chemicals or things that they've got to get rid of. So, as I said, loads of jobs there. These are ones from the Royal Society of Chemistry's website of common careers for chemists. Obviously, another key thing, and particularly at the moment, we're going to go through some difficult economic times in the next year or two. You need to know that you are able to earn money. And I think chemistry graduates are generally better paid over a lifetime than graduates of most other disciplines. So that's not to say that chemists generally are paid better than a medical doctor or a sort of top lawyer. Obviously, there are disciplines where you do get paid almost guaranteed higher wages. But overall, we're in the sort of bracket just below something like a lawyer or a medical doctor. So that means that these figures are a little bit out of date now. These are sort of 5 years or so old. But what it means is over a lifetime, we can expect to earn something in the region of 180 to 200,000 pounds more than those who haven't taken a degree. So that's just, I wouldn't dwell too much on that number. It's more just to show that if you want to earn money in a career, chemistry really offers that. So it's just a sort of reassurance that as long as you're driven as a person and you go out and look for work, then you'll find it, and you can do very well financially. So hopefully that's in your mind now. You might be sort of thinking, yes, okay, I think chemistry does sound like a good idea for me. It really suits me, my personality, my interests. The next question is, where do you go? So here, really, this is my chance to tell you a little bit about Plymouth and why I think Plymouth is such a great place to come and study. So here's just a picture of, if you've not been to Plymouth before, here's just a picture over the top of the city, and you can see Plymouth Sound here in the picture, and the university just in the foreground there, and the position is where the photo is taken, basically. So you can see that all around the university, there's ways to get, and around Plymouth, there's ways to get out into the countryside. but also that the university is right in the middle of the city. And really, I always say to prospective students that the students here almost own the town. They're right in the middle of the city, and when students leave during summer, it really goes very quiet. So it's kind of the real heart of the university, is at the real heart of Plymouth. So I think, I encourage you to come and explore once you're able to, if you've not been before, because I think it's important to know the area before you sort of make a decision about where you're going. But obviously, those of us that are here love the area, and it's part of the reason that we're here, as well as our sort of passion for our work. So, what about being an undergraduate chemist at Plymouth? What's that like, and what are the main sort of flavors of our chemistry that we do here? Well, our motto is very simple. It's learning by doing. And that's, it sounds almost a little bit simple, really, but actually, in reality, if you really understand everything that you've learned and your knowledge, and you're able to apply that knowledge in the real world, then that's when you truly understand something. And I'm afraid I'd like to claim that that's my teaching idea, but it's a very, very old concept that the Greeks knew about a long time ago. And that is that you have to be able to apply the knowledge that you get. So our job as lecturers is to give you lots of interesting resources and ideas, techniques, knowledge, and then slowly draw you towards being able to use that knowledge and actually be able to operate instruments, as JN is here in this picture, by yourself, so that you can actually attack problems head on with your own skills and not be completely led there by a teacher. So that's the graduate that we is our aim to sort of to coach and train. So the course here at Plymouth is also RSC accredited, and that just means that our professional body, the Royal Society of Chemistry, has come into our labs and looked at all of our teaching material and our syllabus, and they said, that's absolutely spot on what you need for a chemistry degree. You're doing all the right things and you're doing them at high quality. So we have the RSC accreditation for our BSc and M-Chem course. So I would encourage you to look for that in other degree courses and check that is available in those courses, because it really gives you a sort of some good confidence that the course is up to scratch. Chemistry in general, as I said before, has high employability prospects. Our course, within 6 months, which is a bit, I always think it's a little bit short to make a measure. This shows you the stats for where our graduates are. So interestingly, 1 in 5 of those graduates are going on to do further study. That's very heartwarming for me as a lecturer, because it means that those particular students have not only been quite inspired by their degree, but they've been so inspired they want to go further. They want to take their studies and develop their intellects and their knowledge base further and get better. And then we've got this blue segment, which is the other largest segment, which are those in work. So we've got overall 10%, still looking for work, perhaps having still thinking about what they're going to do. It's very early after they finish their degree. But overall, you can see people are just getting on with things, and they're getting into new work and new study in general. So good employment prospects, but to have those, you need a highly practical and hands-on course. You need people who are able to perform their science, not just talk about it. So that's something we really work on at Plymouth. Every experiment, we will make sure, if we can, that you are the one doing the science. You're not in a big group kind of watching one person do it. And we also have a wide range of modern instruments up to the standard that would normally be expected at sort of base level standard for industry, which means that when you go for a job in a research lab, or if you take your science further, and you'll actually be able to say that you've used the most up-to-date instruments that are either identical or very similar to the instruments that are used in those professional laboratories. Now, I think most universities will have some instrument base, but in Plymouth, the interface between undergraduate students and actually getting on and using those instruments is very fluid compared to a lot of other universities. Our students do sit and operate instruments. They are trained to use the software on those instruments and handle the data that comes from them. And I think you'll find that's quite rare, and it's one of our focuses at Plymouth that we're proud of. So yeah, hands-on means hands-on. It's not just sort of saying that. You need to be able to actually put samples together, do your chemistry, and then analyze them as well yourself. So all that's possible with our laboratory facilities. If you haven't been in to see us, if you can, next year, once the labs reopen, please come and see us, have a look round. But the pictures hopefully demonstrate that our teaching labs on the left are modern and up to spec and relatively spacious, and they're not too big. You've got typically we have groups of around 20 in a lab at a time with a lecturer and a demonstrator. So you really get, we will actually come around and show you how to do things and demonstrate and practically show you, as I said, hands-on training on how to do your chemistry. We've got the state-of-the-art instrumentation, so some examples here on the right, and we've also still managed to keep going our expert technical support. We've got people who I did my PhD with actually are also teaching you as the technical experts in the laboratories. So we've got really good people, and they're also, not only do they get on with their sort of day-to-day research work, but they're also really good at teaching students in those laboratory situations as well. So the kind of transition usually is kind of like going from an undergraduate lab here over and eventually being sort of, proficient enough to move into some of the research labs and do a research project, let's say. Now, this is something I can imagine if you've sort of just started thinking about science and you're just really keen on your chemistry and you want to get into lab work. This probably isn't going to totally bowl you over with fascination at this stage, but it's important to mention that you do actually get trained in something called ISO accredited laboratories, or ISO certified laboratories. And those laboratories are run to standards that are used in industry, and not just in chemistry labs, but also in any kind of working environment. And that's something that later on, when you go for employment, having knowledge of that and doing good quality work in a workplace and how to actually kind of monitor whether or not you're doing good quality work through paperwork and also calibrating instruments and things, you'll actually be able to show that you have experience of that. And we give our students a certificate to say that they've worked in these ISO laboratories. So as I said, that may not interest you yet because you just want to do chemistry and you're interested in how molecules work and how atoms work. But this later on is something that we know employers really value. So it's something that we offer as a value added for our course. You'll be taught by excellent teachers, okay? And I know that you'll probably think, well, they're bound to say that, but I'm going to show you some good evidence for that, which should convince you. Now, obviously, as I said, we like to have practical hands-on teaching, but we also want to make sure we've got our research-informed teaching. You come to us at university because not just to learn from teachers, but to also learn from researchers, people who are at the cutting edge of their research field and learning about what's going on in the world today, not the chemistry that was done in 1918 or 1920, which is a lot of the foundation chemistry ideas are from sort of after the First World War. So we do this. Our teaching's all done in small classes. So the cohort is typically between 30 to 50 per year, and we have we start tutorial teaching from the beginning. So you'll be getting together in groups of 5 or 10 on a weekly basis initially. So we really sort of focus in on talking to you, finding out what you understand, what you don't understand, and then that's kind of how we work. If you didn't know, my belief is that you come to university not just for access to labs and teaching and research, but also for the discussion. And I've learned that more and more as an academic. You know, what's really important is keeping the discussion alive in science in particular. So it's not just enough to come along and plug a load of information into your mind, into your brain, and then walk away and that's your degree. It's developing ideas with people that's the fun bit. So we encourage all our students to get together in groups, work together, discuss their science, and I think that's what you'll find is one of the best things about university. Okay, so back to our course. Overall, the assessment for our course is 70% coursework. Okay, and that's largely because we have a final year project, which allows you to go into a lab and do a particular bit of chemistry that you really like, and something that you might want to take further in your career. So that becomes sort of a large chunk of your coursework mark, but also generally our modules are roughly 50% coursework, 50 exam, but the overall degree is 70% coursework. I think that's for those of us that are not don't have photographic memories and fast recall and handle extreme pressure under exams very well. That allows people to really shine, and there are a lot of people who are excellent scientists and not very good exams. So that's an opportunity there. But saying that, those of you who are good at exams, it's still, you know, a large percentage is based on that mark. So you do have an opportunity to shine there too. So you're hopefully thinking, this course sounds good. I'm going to consider it. But what you really need is some actual information, not just from me, because I'm the admissions tutor. You want to hear from our students. Unfortunately, the current situation, that's not so easy. If you're able to visit us later on this year, then I would encourage you to come and talk to our students and find out from their story what's good about our course and why they enjoy it. So please do that. But in the meantime, what I do have is some data from last year's students who've now graduated with an anonymous questionnaire called the National Student Survey. And this means that people can say what they want. There's no comeback really to the students because it's anonymous. So for our National Student Survey last year, we really did extremely well. We were really happy. So 96% of our students were basically said we could teach, we could explain things. But what was really heartwarming was some of these other scores. So all of our students who graduated last year, who did the survey, said that the course provided them with opportunities to explore ideas in depth. Okay, so it goes back to my example earlier of just taking a leaf and following the chemistry back in time to discover how the chemical machinery has made its way through. So those kind of ideas are what I call, you know, deep understanding. 100%, all of the students that took the survey said that our course was intellectually stimulating. Now, if you come to university and you leave feeling like you haven't been intellectually stimulated, then you know you've really not made a good choice. So this shows you that all of our students felt like that and felt like they'd really moved forward in terms of their understanding after their degree. And another one, 100%, and this one's really important. So 100% said that they could contact staff when needed and receive advice and guidance. So what that means there is that particularly in these times coming up where, you know, there's a little bit of uncertainty in the next few years, you can see that our students know that we've got their back. Okay, they know that whenever they need us, they can get hold of us, and they're going to get guidance and advice. And that advice continues. After you graduate, I still have graduates coming back and asking for advice for interviews or going forward in their career. So it's that connection again and that discussion with us that's really important. So how do we do when we ranked up against all the other chemistry departments? Well, we're #1 for academic support. So again, if you are concerned about the next few years and making sure that you're supported, whether it be online or in the lab or in lectures, you can see again that we're doing this really well. So you will get supported. In terms of overall teaching, we came 4th out of all of those 57 chemistry departments, and 2nd for feedback, for actually coming back and talking to our students and telling them what they could do better, what they did well, and then kind of that being a constant process of improvement. So hopefully you can see now that no matter what I say, you can see that our students will also agree with it. You can see that they are really happy to put their names and on the and actually sort of say what they think about the course and show that it's a good course. So what makes a good course? Well, as we've said, it's good that the RSC accredited the course, but what do we need in our course to make it sort of a good all-round course? Well, obviously you need knowledge and understanding. That's giving you access to the textbooks, the databases, the things that you need to understand your chemistry. You need to develop laboratory skills, and I've mentioned that already. You need to be good at problem solving, using those skills to apply and your knowledge to apply that to real life problems. And I've mentioned that already. You need to be a good communicator. It's all very well doing an excellent bit of science that's going to blow someone's mind, but if you can't actually tell them about it, it will never make it past into the public domain. So it's really important to be a really good communicator. We will train you and help you improve on that so that you can write documents, you can stand up and give a presentation with confidence and get your message across, which is tricky, believe you me. Also, finally, project management. We think that's another of our 5 pillars, if you like, for your degree, is to make sure that you're able to manage your time, plan and set objectives that are realistic, deliver on a project. And that's your final year project. And so there's a chance to develop those skills and also demonstrate to a potential employer or a research leader that you can do that. So you come away with some evidence of that. Lots of support, including us as your lecturers around it in the university. So it's really important you have good technicians, which we have here in Plymouth. You have support with careers, library, fellow students, and you get a personal tutor from week 1 of our course. So even induction week, you actually meet your personal tutor, and that discussion starts straight away. Excuse me. So one of the things that we were actually, our program pioneered in early days was something called the PALS system, and that's called the Peer Assisted Learning Scheme. So what's PALS? Well, it's actually run by the students for the students. Usually it means a group of, usually stage 1, first year, second years get together, perhaps with some students from the year above, let's say, who are sort of assigned as tutors. And it's a chance to sort of discuss informally problems and ideas that you've got. And as I said before, it's all about the discussion. So this is another opportunity to have discussion with students in different cohorts, different years. So that people really like that. It's really a great opportunity to discuss your chemistry. We also have the Chemistry Society, and they get together and have socials and have fun, doing sort of geeky chemistry stuff. So this is our chemistry, sort of being built with retort stands and coloured chemicals to make a nice Christmas tree there. So that's the sort of thing they get up to. So yeah, we would like to encourage students to meet each other, not just in their own cohort, but across other years of the programme. In terms of how we've moved on with the learning environment, particularly important at the moment is that we've gone completely digital, and we use the Moodle platform for delivering all of our resources for different modules. So that means you can go along to our website, you have all the course materials, the module guidance notes, i.e. laying out what you're going to be the syllabus, if you like. You'll submit your assessments online through this platform as well. And I think these days most people will be quite used to this idea and almost expect it. Particularly useful at the moment, obviously, with the virus going on, and we're able to still be able to deliver material and also sort of meet up online with our students. We use something called Panopto, which is a video platform. What that is when I go along and give a workshop or a lecture, I'm filmed throughout by the lectern, if you like, and that film is then put up on the Moodle website, shown in this picture, and you can then sort of go back to parts of the workshop or the lecture where you didn't quite get a concept or you missed a detail. So it allows you to go back and sort of revise things with video, as well as looking at your notes at the same time. And we still absolutely insist on people taking notes as well. It's also part of the skill of being able to assimilate knowledge, is how you record it and kind of review it afterwards. So that's our digital learning environment on our course. Here's a sort of breakdown of, roughly speaking, how you sort of progress through the years. So we have our foundation year, and that's particularly important for people who've come in through different routes, perhaps through professional experience, or mature students who've taken a break, coming back into university after a while. So there's a route through there to come into year one. For the majority of people coming straight into year one, you'll be learning the core chemistry that you need to progress as a chemist, and that is very similar across all degree programs in the country, because it really has to be a solid foundation for you to move up with. Some of those concepts you would have dealt with before in your courses, but usually what we have to do is kind of fill gaps where people don't know things, and if you've dealt with a concept before, we're developing it further and sort of improving that understanding. You also get, we also have maths sessions to keep people ticking over with their math skills for those who've done maths already. And if you haven't done lots of maths in previous studies, then that's a chance also to beef up your understanding of maths and use. We have IT sessions which teach you the skills you need to work with different databases, software to do your chemistry and communicate it. And we have professional skills, so you start looking at your CV straight away in your personal tutorials, in a nice way. You know, sit with your tutor and start talking about it. But we have this idea of developing you as a professional from the start of the degree, not leaving it right till the end and sort of doing it in the last week as a rush before you sort of go out to get a job. So there's a kind of ongoing professional skills discussion and training sessions throughout. Year two is where you get a chance to broaden your skills and learn more core chemistry beyond some of the things that you've even touched on with your current studies. Developing professional skills ongoing, and the next sort of step, which slightly sort of will set us apart from other courses, is where we have modules on analytical techniques. So our students go out and actually go on a field day and collect real samples from an estuary nearby, and then come back and do a series of analyses on those on your own samples, which I think everyone really enjoys. And we have modules on which will teach you about those analytical techniques, what they are, how they work, how you use them, how you manipulate the data. So that's a really kind of core part of the degree that again sets us apart from many other courses. Year three, as I said, we're trying to take you on a journey, on a path to, and by the third year, what we want you to do is be able to apply all those 5 skills that I mentioned earlier. And the best way to do that is to do that with a research project. And so you have a research project in that year, which goes throughout the whole year. For me, that was when I really, really got into science, was when someone said, here's some chemicals, here's a reaction, we don't really know what's going to happen, so can you go away and study it for 6 months? And I was like, wow, this is amazing. So I think there's that's where you actually get to start applying and using your knowledge in anger at that point. If you are really keen on analytical chemistry, you know it's where you want to go, then from the start, you can actually opt for doing our MChem year, which is a 4th year, and that's very much focused on becoming a professional analytical chemist. So we offer placements, opportunities to do 12-month placements. So recent student placements have been at GlaxoSmithKline, and also in areas companies more local, such as Imerys, which is down in Cornwall. So that's a clay works and processing plants. And so really what we try and do is, rather than sort of have one offer of 20 places in one place, we tend to do placements on more of a tailor-made discussion, really. They're tailor-made based around a discussion with your tutor. So if you're really interested in a particular type of industry, then we sort of investigate what potential placements are out there. We have a full-time placement officer, Pippa, who's also is actually a chemistry graduate. She's fully aware of what chemists wants and needs, and she is there to facilitate that and have those discussions with you as well as your tutor. So we're quite geared up for offering really nice tailor-made placements for that 12-month period. In your 3rd year, it becomes at that stage. Now, some people don't want to do that. So there's, well, I don't want to take a whole year out. I want to get on with my degree. So how can I do that and still get a placement? Well, you can do a summer placement. We call that chemistry work placement, and that actually can become part or all of your project that you use for your final year. So you can actually go into industry and actually use your research project to sort of actually solve a problem for a particular company or a hospital or something. So that's quite exciting, and I think if people can do that, it's real applied chemistry, and so you can actually use your skills to help out. And if you don't want to do that, then usually what I would say if I was your tutor is, well, let's get you some work shadowing. You know, if you can't get into a 3-month placement or a 12-month placement, let's go and do just a week with this company or a couple of days with this professional. So there's a discussion around really focusing, getting experience if you can. So all of that's going on alongside the degree, and you get a chance to sort of discuss that and work out plot your course as you go along. So as I said, we offer this final year MChem. Now you can apply for this direct, or if you're not sure at the moment, you can always opt for this, assuming you get a certain grade, approximately midway through your degree. Then the MChem is for getting a sort of people on a professional career path towards analytical chemistry. So it's a training to become an analytical chemist that is someone who employers will welcome in with open arms. So we've talked to employers, and we've written down, we've asked them what they want, and then we've put that in the course. Yeah, you can see that we're academic geniuses, can't you? But sometimes those discussions don't happen, and so we've made sure that we've gone out and spoke to employers and found out what they want. So some of the things that I mentioned already, this ISO accreditation or ISO certification, it's very clear that employers, particularly in chemistry labs, really value this very highly, and they've told us. So this is in the MChem, we extend that to include another type of certification 17025, which is skills in actually being able to work in a lab that can calibrate and do analysis. So again, lots of problems on hands-on online, hands-on learning in the lab using the instruments that by then you're more familiar with and actually almost sort of comfortable to start working a bit on your own. And this is again done in the ISO 9001 certified labs I mentioned earlier. So you can again really boast about that when you go out into the employment field. What does it look like when I come to university? How often do I have to be in? Well, the good news is you're almost in every day as a chemist, as a science student. The expectation is, there'll be at least one workshop or a tutorial or a practical going on. You can't see, these are quite small, but you can see that this is a first year timetable, and you can see that most days people are in doing things, and there's practicals going on sort of every week, and workshops and tutorials. So you're talking to us all the time. You see, there's a bit of a break on Wednesday, and that's Wednesday afternoon is in all universities sort of sports and clubs and activities. So that's kind of left free for actually going out and doing other things. So you're talking in Plymouth, you're talking about 16 to 20 hours contact time a week typically, and we expect you to do the same time in self-study as well. So you're going to be busy with the course. You won't be sitting around, and you'll be doing lots of stuff and engaging with people, your colleagues and us. So I think people have a lot of fun. Now, some of you might already know Plymouth and Devon, and in which case, feel free to skip this. But I think you'll agree, if you do live around here, that it's a great location. Students who come to Plymouth from elsewhere, and those who are local, really enjoy living in Plymouth in general. Once you're outside of the kind of halls of residence side of things, the private accommodation around Plymouth is generally quite cheap, and the sort of living in the city is generally cheaper than a lot of metropolitan larger cities. So there's the advantages there, and then the advantages of just having lots of like really great scenery and nice places and beaches to get to without a lot of effort, really, just a sort of short bike ride or train ride away. So if you really come here and explore, you'll find there's some fantastic places to go in your spare time. Have a look at what's available through the Student Union. I think we've got I think it's something like over 150 clubs on offer. So there's going to be almost too much to choose from. But I guess if you've got a particular passion, I really enjoy surfing. So for me, being in this area is really key for doing that. If you really enjoy a particular hobby that you've got, have a look at the Student Union, see what they've got, and hopefully, you'll find that there's something there that will match up with your interests, something you can get involved in. And if you're not, then we always encourage people just to go out and try things. You never know. If you don't try, you never know whether or not you enjoy something. So there's lots of opportunity there for really developing yourself, getting to know people, and having a lot of fun. So that's our student experience. I'm just going to finish off the last sort of 5 minutes of this talk, just to let you know who we are, who are the people that are teaching you, and what makes them tick. So coming to Plymouth, you'll be taught by research active staff, and you'll be taught by very enthusiastic staff, people who really enjoy what they're doing. And we want that to kind of rub off on you and help you develop as a scientist as well. So that's all about bringing new ideas and discoveries that we're doing in our research into the teaching that we deliver. Now, Plymouth's quite quiet about its research. Often people, even in Devon and Cornwall, don't really know what goes on in Plymouth. And we're getting better at sort of advertising that. But basically, within the chemistry department, there is world-class chemistry going on. We're publishing in very high-impact journals, particularly around areas of the environment and energy that I mentioned earlier. So I'm just going to give you a few examples of things that we do. So a lot of our industrial-related research has been based around the nuclear sector. So one of my colleagues, Maurizio, has been working with EDF Energy to look at nuclear fuel cores and model the structures inside those cores. And there's been a legacy of working a lot with the analysis of oils in our chemistry department as well. So there are experts in working with what's a very tricky mixture to untangle chemically and study. So we've got a broad and a long time legacy of experience there. But that's more what we call applied research. We also are really into our blue skies research, and that takes us all over the world. We're all, most of us are analytical chemists in terms of our research, so we develop techniques. This particular bit of research is a really nice example of how you can apply your knowledge as a chemist to solve problems. So this paper is talking about particular molecules which are only present in something called diatoms. Okay, so it was discovered that in certain diatoms, these are sort of small sea ice algae that sit at the base of ice flows like these ones. They only exist in ice flows, and there's a particular molecule that can be found in these after these diatoms decay, which is specific to them. Okay, so we've discovered this. Our colleague, one of our colleagues, has developed a technique which will actually analyze this at very, very low concentrations. So why is that interesting? Well, it's all about the creative thinking really here. So what happens when the sea ice melts, okay, is that every season is that sea ice, those diatoms then sink to the bottom. So diatoms are made of almost like it's silica. It's almost like glass, like frustules. So they're quite dense and they sink straight to the bottom of the ocean. So if we, as at the bottom of the ocean actually is quite calm. There are some currents down there, but compared to what we see with the waves crashing around us when we go to the sea, the bottom of the ocean is quite calm, and the sediments build up over time. Okay, so as those sediments build up, obviously those diatoms are kind of mixed in with that sediment. So if you're actually able to collect a sediment, so let's say you get a tube of sediment and you bring it back to the lab, you're able to identify, perhaps with something like carbon dating, how old those different parts of that sediment are. So you can say, well, that one's 10,000 years, that's 30,000 years. And then you're able, if you then sample from those different sections of that core, you can then look for molecules. And my colleague here, Simon Belt, discovered these particular molecules for the sea ice diatoms in these cores, and was therefore able to join the dots there and say, well, if those diatoms are there at, let's say, 30,000 years ago, then that means there was sea ice over this particular bit of the ocean. Okay. If you know where sea ice was 30,000 years ago, then that's useful. So if I go around and then collect lots of cores from all around the North Atlantic Ocean and the Arctic Ocean, let's say, I can then find out where sea ice was at particular parts of history. Okay. Again, let's make another step. What do we do with that knowledge? Well, that knowledge gives us information about climate change. It's very hard to know what happened 30,000 years ago. So by being able to see that where sea ice extent was at that time, we're able to get much more information about how the climate changes and over the very long time scales. Okay. Now, in order to do that, you need to be an analytical chemist. You need to know how to be able to measure certain things at very low concentrations well. And you need to be good at field work and be able to sample. And these are things that we will be teaching you on the course. Here's my area of research. So I go out on deep sea research cruises, collecting seawater samples from the surface all the way down to, let's say, 5,000 meters at the bottom of the ocean. And then we're actually studying the chemistry of particular elements and how they move and cycle through the ocean. I'm particularly interested in iron because iron is somewhat of a nutrient for the ecosystem in the ocean. And if in certain areas of the ocean, if you don't have iron, then you don't have very many, you have a sort of very slow ecosystem. There's not a lot of growth of phytoplankton in those areas of the ocean. Phytoplankton are at the base of the food web, therefore the whole food web is kind of sort of held back by the availability of iron. This is particularly true in the Southern Ocean around Antarctica. And in fact, with colleagues, I've just came back from a research cruise in the Southern Ocean over Christmas, and we were observing really interesting sort of movement of iron within the ocean in the Southern Ocean, feeding the phytoplankton down there and sort of controlling the food web. So there's lots to be learned out there, and we call this blue skies research. It's really exciting, and I hope to be able to tell you more about that if you join us next year. So more locally, just a last example. This was an incident, this is around 7 years ago, where there were a lot of seabirds washed up on the coasts of Devon and Cornwall. No one really knew what had happened and why. It could have just been put down to a sort of an unknown phenomenon. But we, on the 6th floor of the Davy building in Plymouth, the scientists here, Paul and Steve, were able to invite people to bring samples in to test why these birds are being washed up. This was a really big disaster. It was spread all the way along the coast of South Devon and Cornwall. Using the analytical techniques I've mentioned, they were able to identify what the substance was. Okay, and then it turned out to be something called polyisobutene. Okay, and you can see that molecule down there in the right-hand corner. And polyisobutene is transported in tankers across the world as a lubricating additive used in the production of certain oils. So it's actually something that's quite commonly shipped around in tanks, and it turned out that certain companies were actually discharging tanks of this compound or washing out tanks off very sort of close to the shore in the channel. So that discovery led to change in legislation. It led to basically improvement in the quality of the environment. Okay, so you can see again how using these techniques, using your imagination as a chemist, can really bring about change in a real way. But you need to be able to use research instruments and analytical instruments. And as I said, that's a real focus of our teaching in Plymouth. For chemists, analytical instruments are like our eyes. They are, or our senses. They are what we use to find out how molecules work, whether or not molecules are actually there, what atoms are involved in a particular compound or a sample. And you can't really tell whether you're doing a good chemistry unless you can analyze what you've made or what you're working with. Okay, well, thanks for bearing with me. I guess the nice thing about these kinds of talks is you can pause them if you wanted to go for a cup of tea or a cup of coffee during the middle of that. Just finally then, just to talk about our offer. So to join us here in Plymouth to do our degree course, our UCAS offer is 96 to 112 points. Typical sort of types of grades are something like a BCC at A level. We're really after people with a B or an A in chemistry, ideally. So we want to see some evidence that you're really enjoying your chemistry and you're doing your chemistry to a high standard. In terms of the foundation year, as I said, for people looking for a different route in the university, the tariff is around 56 points. And we also consider sort of professional qualifications as well, and sort of evidence of being able to of some kind of scientific training. So feel free to contact us about that if you're interested. The university offers guaranteed accommodation for anyone who makes us their firm choice and first choice during applications. So if you're sort of absolutely certain you're ready to sort of make a decision, you want to come, then things can happen quite quickly in terms of just getting everything sorted out for the year that you join us. So yeah, you can get your accommodation sorted and everything else that you need. So to sum up, we've got a degree which is assessed by 70% coursework. You know that it's a good quality Royal Society of Chemistry accredited degree. You know that you're going to be taught in ISO certified laboratories, and you know that the teaching that you're receiving is at a really high standard, as I've shown you with the National Student Survey. You know that you can go off and do a work-based module or industry project if you wish, and when you come to Plymouth, you know that you're going to be in the centre of the action of the city, in a friendly place right by the coast. So there's some real, advantages to that. So thanks for listening. I hope you enjoyed it. If you are interested and you're ready to make decisions or anything like that, feel free to contact me. So my office telephone number is there. I'm currently not in my office. I'm working at home, so that number won't connect. But if you do want to email, then please email chemistry@plymouth.ac.uk, or feel free to ring up the university and talk to our admissions service. Any other questions? Anything you want to know? Please feel free to get in contact. The fact that you've watched the presentation and you clearly have some interest in the course means I'm quite happy to talk to you one-to-one from now on. So that's all from me. I wish you a good day for the rest of the day and whatever you're doing, and hopefully speak to you at some point during the next year. And best of luck with whatever you're doing, and stay safe and look after yourselves.